use the word elasticity or cloud.
Yeah. Okay. Just take it from the top. I'm not gonna. Thanks again.
Yeah, I think there's some kind of keyword that I keep saying that cuts off the chat. I don't know what it is. It must be like some kind of Pavlovian thing with the camera, but nonetheless. So most virtualization environments, they do have some type of elasticity built in. What am I really talking about when I say elasticity? It's the ability to really tailor the amount of infrastructure that you need to basically your business need and to your wallet. So in the case of for APIs and API developers, once you start getting your code base out there, it's the ability to really early on get your code base into maybe a smaller server, a smaller Linux image, something that's cheaper but can really let you test out the waters to see how the public will respond to what the kind of the idea that you're getting out there. And then later on, as business starts to boom, really leverage more cloud horsepower to really, more infrastructure horsepower to really be able to service your clients more. So, I mean, that's kind of really high level of looking at it. I know Amazon has some great tooling for this. VMware and some of the other virtualization environments, I'm just going to say virtualization just generically, also have some great tooling, but again, 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 generically, also have some great tooling, they do also offer Elastic Beanstalk, which is more platform as a service, that has some excellent kind of tooling there to aid with the same idea, but I'll kind of stick to what I kind of know. So we'll talk about the Elastic Compute Cloud. I think that finally we got through it, which is, I guess, something to celebrate a little bit. We got through that question. So
yeah, we did.
Do we have any questions or?
A couple comments. Maybe the stream is too elastic.
Okay.
No one likes.
Am I yelling?
No, I think.
Woke up my kid. That's awesome. Sorry, Cyrus. I mean, if we're kind of waiting around, would you like me to get into an example?
Just quickly, a couple cloud sort of related questions.
Sure.
How is Amazon different from other cloud providers?
I think it's so the other major cloud providers is they at the very high level they all kind of offer the same type of services when they're in the infrastructure as a service kind of business, which is ability to start up servers, whether Linux based, Windows based, and quickly be able to access them and start getting them into the public realm. Where Amazon really kind of, I think, differentiates itself is it's been in this game for quite a while. It's got a lot of horsepower. It's really dispersed in its implementation, and it has, I think, something like 7 regions that it's in now, all over the world. Several in the United States, Europe, several in Asia. Now we're getting into South America as well too, with one Sao Paulo, and they've been kind of doing this longer than everyone else. Another differentiator is that they've kind of built up their capabilities when it comes to scaling really well. So you can both have the ability to have your own administrator scale up really easily, so start up new images, quickly add them to their Elastic Load Balancer, or you can do it kind of automatically, which is leverage their auto-scaling capabilities to configure your images to start up when a certain kind of event hits. And the term event is very generic. What I really mean is, let's say you detect that the CPU on your little mini cluster, the CPU utilization is starting to peg, it's starting to get quite high. Well, you can configure it so automatically the autoscale API will start up another Linux image for you, or start up another image for you and add that to the load balancer. All of a sudden your cluster grows. It's kind of hands-off thinking that they have. Another really kind of cool tooling that they have, and I mean, VMware with their in-house cloud tooling kind of provides this, but it's their CloudFormation, which is templatized infrastructure, overall infrastructure. So really easily you can take a template that identifies the type of image, or like, for example, Linux image that you want, and the type of database or databases, and the firewall configuration between them, and just with the press of basically one button, run that infrastructure all at the same time and have it communicating with each other. No need to individually configure those things. It's kind of a really neat idea when you really quickly want to get, let's say, a LAMP stack out there. So for LAMP is kind of an acronym that even I had to Google not too long ago, but get your Linux, Apache, MySQL, PHP infrastructure out there and be able to really quickly get a kind of a dynamic application or API in this case out into the world.
Cool. We have a question from James.
Oh yeah.
How clever does the algorithm need to be to avoid feedback loops in Elasticity?
So that's a good.
Or is it something Amazon just does for you?
No, I mean that's a very, very good question. This is something that you kind of do have to tailor. So, and feedback loops are a traditional kind of load balancing problem in that you can start getting oscillation where you scale up because let's say CPU has gotten quite high, and then you've set a lower threshold for when you would scale down. So you do really have to tailor it to find that sweet spot, like where you ideally want to keep your CPU going. So it is more configurable, I would say. I don't know of any specific ways they have to minimize feedback loops. They also do have kind of a ramp up time. So you can say, okay, I want to, when you create a launch configuration and then when you set an alarm for the auto scaling group to say, okay, utilize this launch configuration at this time, you can say, okay, give the server a certain amount of warm-up period, and then once that warm-up period's done, then add it to kind of the autoscale group and to the load balancer, so essentially have it start processing requests. But this is a tricky thing. From my latest and greatest research on my previous experience, they don't really have anything to it. It's kind of up to the configurator to figure out that, but it is a big problem. It's kind of one of the classic load balancing problems.
Okay.
Thank you.
Hopefully that answers your question,
I hope so.
James. But if it doesn't, just chat in more detail. So did you kind of want to go into your scenario? Or?
Yes.
Okay.
So I do have a kind of one scenario just to set the tone while we were kind of waiting for more questions, and time's getting a little tight, but let's just get into it. So the classic scenario that I always have in my head is a gentleman by the name of Trevor Smith. He's a fictional character, but let's just say he just got his master's degree from the University of British Columbia, computer science and commerce. During the course of that time, he created this algorithm that he thinks is like the greatest thing since sliced bread, and it's what he calls the crystal ball.
You want to take a quick question? We are here to take questions. So
okay, so how do the various providers differ in terms of pricing? So I would say that's something I would have to take off the line. I know Amazon is the most popular provider at this time. I don't know if that means that others are trying to become more the Walmarts of the cloud world and really kind of beat them on the cost front. So that is something that I would probably have to take offline. I can guess that they're very competitive and they do have different pricing models. So if, for example, for just pure images or instances themselves, they do have various sizes of instances that you can tailor to your needs. So starting from T1 Micro, which is kind of their famous one in that they offer free usage of it it basically works out to about a month, so 750 hours. And then it kind of ramps up from there. M1 small is usually about 8 cents an hour, M1 medium is about 16, and it kind of goes up to massive sizes. I'm not sure how competitive things like HP Cloud, what are some of the other Savvis, although I'm still kind of waiting to see how Savvis's really cloud presence is going, but I'm not sure how competitive they are. The thing there is you do have to kind of weigh the cheaper costs versus who has the more tooling, who's been in this longer. And I think Amazon for now has other people beat. I am curious where Google I/O goes. I've always been curious where, what Google would bring to this or what other kind of larger technology companies would bring to this. But it is something I could definitely, if you want to kind of email, like maybe send us your email information to techtalk@layer7.com, something that we could get back to you on, or at least I can point you in the direction for some more literature on the matter. My gut does tell me, though, Amazon is either very, very competitive and or just the tooling that they have kind of does a better cost-benefit analysis there.
Okay.
All right, so we can get back to
Mr.
Trevor Smith. Okay, so
and, maybe talk a little bit slower.
I'm trying to make up time.
I know.
We lost time. No,
I know. We lost a lot of time. We apologize for that.
So Trevor Smith, master's degree from UBC, or University of British Columbia, in computer science. He created the crystal ball algorithm. He's a huge sports fan. The crystal ball algorithm basically crunches through data, I guess. We're good? Okay. Crunches through data, that both historical data and current data that's trending on social networks and in the media to tell you sporting event, the likelihood of certain sporting event, I would say, output. So the likelihood how a sporting event will turn out. So, for example, Trevor really went after NHL and NFL. You can supply it a game that's going to happen in the future, and depending on how close it is to the present, like how soon it's going to occur, it will tell you what team is most likely to win, and it'll tell you with a certain percentage of likelihood. So this is the algorithm that he developed. Now, as part of his grad work, he wrote this in Java just because he understood how the Java and J2E frameworks work. Once he finished his graduate degree, though, he decided, okay, I want to monetize this. So how can I go about, if people are interested in this, maybe they'll use it for, either to settle bets with their friends or kind of more sport betting sites would leverage this. And so he wanted to monetize it in a way where he would, instead of getting it out into the end users' hands, he would get it out to the API developers, which will turn around and get it out to the end users' hands. So in our example, what Trevor did is he kind of scraped together whatever he had in his savings. He kind of scraped together whatever he has from his parents and raised up a couple $1,000s, and he came to the very first question that a lot of API developers I think have, and this is both, mom and pop type API developers or even enterprise architects, and it's, do we host it in-house or do we host it in some kind of virtualization space? And obviously by the topic of the conversation, I think you know where I'm going with this, is he decided to go into Amazon. And so to do this and to keep cost minimum, in this case he decided to turn on a Linux image, a T1 micro, which, as I've said, it does have free usage for a short period of time, kind of just to test the waters and to get it publicly out there, install Tomcat on there, and take his code base and throw it into a Java WAR, so J2E WAR, Web Application Archive, and just deploy it on there, and boom, within a matter of minutes, once he has this all deployed, he has a public API that's out there called the Cloud Service, or it's called the Crystal Ball API. And with that, people can ask questions of, hey, who do in next game, what is the likelihood that they're going to win, with a date that game's going to occur, and it'll get a JSON response back. So that was the very first thing. Again, he leveraged Amazon's Elasticity to utilize part of their service at something that kind of mapped to his wallet, which was as cheap as possible to get his idea out there. And with that, he was able to get a URL, EC2, blah, 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 the traditional public DNS, that he could kind of start shopping around to various, both venture capitalists and to app developers that are kind of out there. So that's part one. Do we have any more questions, or should I keep going down this path?
You could keep going.
Okay. So as kind of with Trevor, as time went on, his API started to kind of gather some momentum. More and more people started to kind of pay attention to it. So and he started to notice that the performance on his APIs, on his Crystal Ball service or Crystal Ball API, wasn't as good as he liked, especially now that he had some paying customers. It just wasn't, it wasn't something that, he needed to basically add a little bit more horsepower to get a little bit better response time. So again, this is where Amazon's Elasticity kind of comes into play. He can't quite take his T1 micro image and turn it into, let's say, an M1 small or M1 medium, something with basically more RAM and more CPUs. But what he can do is, while that one's running, he can boot up another larger image and take his code base and deploy it on that. And it kind of to minimize outage time in a fairly seamless manner, turn the micro image off and make the other image live. And how you can kind of do this a lot of times is either using an Elastic IP by just switching the Elastic IP from the T1 micro to the new image, or basically having a load balancer in the front end that all your using their Elastic load balancer capabilities that all your traffic kind of routes through, and adding your new image to that and quickly taking the other one off. So basically you all of a sudden have more horsepower. Cool thing there again is he didn't need to go out and buy a giant server, spend a bunch of upfront costs there. He basically paid for exactly what he wanted on hourly. He had a small server for a while that was free, or went into kind of a fairly cheaper rate, and eventually he just turned on a slightly larger one that was more expensive, but that kind of met his new business needs and his more the needs of the API kind of users that he was starting to get. Okay. So
is he getting developers to that API building apps off of that?
Yeah, I think I did gloss over that part a little bit. Yeah. His idea would be that for the Crystal Ball service, so let's say if you have some kind of handheld mobile app that you give to people that are involved in sporting results, or maybe that gamble with sporting results. If you are an app developer of that, you would use his API as a part of as another information stream to give to those users, or people like other more online betting sites could leverage it as well. I mean, it is if you do it well, it is kind of a cool idea to kind of really push out there. And it does, again, show as your business grows, as your API business grows, how you can leverage Amazon. Okay?
Okay.
Shall we keep going?
Sure.
Okay. So another, now, the next thing, and this is kind of where really I was heading down, is what happens as your business really starts to grow? So that's good that you've grown your single image, but what happens when you start to notice that before certain events, so in this case, in Trevor's case, things like the Super Bowl, all of a sudden you have a spike in usage. How do you leverage Amazon Elasticity to be able to handle that extra load on your API? And again, I mean, there's various ways of doing it. You can do the traditional, like, kind of cold, warm, hot images that you can bring on. One way of doing it is you can just turn on another AMI instance and add that to your load balancer when you, approximately around the time when you know when your usage is going to spike. Or another one is you can start using the autoscale API, and just kind of as James's question before, you can kind of leverage the elasticity in that you can configure the autoscale API to really tailor the amount of horsepower, the new instances that are going to be used based on something simple like either CPI utilization, or what you can use is you can tailor it to start gathering custom metrics and feed that into Amazon's CloudWatch capability, and set alarms on, for example, some amount of requests per hour that you feel would need more computing power. So again, this is where Trevor kind of starts to tailor his the bursting capabilities of Amazon to his needs. And so for something like the Super Bowl, as you know, more and more people kind of want to know, okay, like, you know, an hour before, what is the likelihood that Super Bowl is coming up? So what is the likelihood that the 49ers are going to win? Well, he can quickly kind of tailor his own horsepower to be able to answer that quicker, and again, have a better kind of user experience, have a better experience for the API, the developers that are users of his API. And
so when he's monitoring the usage of that API,
yep.
Is he manually bursting, or is it?
So he can do
both.
He can do both. So, and there's various ways. You can either literally turn on another AMI instance, add that to, like, let's say a front end Elastic load balancer, or you can have your autoscale group configured and turn on a new one using that, like, by pressing a button, like launch a new instance. Or you can just let the autoscale API kind of handle it on its own, where you've created a launch configuration saying, I want, you know, my Crystal Ball API AMI image to be turned on, and I want it done exactly when requests per second reach 50, because I know that's kind of the upper threshold. And on the same side, and I like to think of this as, like, I've given a talk before where I call this adaptive infrastructure, and I have a picture of a Terminator kind of come on. I also want to scale down in the case that requests per second go, let's say, below a threshold of, let's say, 10, where I don't think I need that much infrastructure. And that's kind of comes back to James's previous question about feedback loop. So you got to really tailor that to make sure that you don't have too much oscillation going on there. So through this example, as we've seen, Trevor's kind of taken his API, and as his business has grown, really tailored it for how much money he's going to spend, and how much money and revenue he's bringing in, and to kind of really keep the user experience as optimal as possible by keeping kind of the performance behaving as best as possible.
So those are the key considerations when deciding on a pure Amazon rollout.
Yes.
As opposed to mixed on-premise architecture.
Well, so that is also a very cool question as well too.
Because
how do you decide? So once his business kind of really starts taking off, he has to kind of take into consideration, do I want all my eggs into one basket? And Amazon being, you know, one of the kind of the premier cloud providers out there, there's some statistics that I've read. I don't know if they're how factual that they are, but something like 1% of the entire internet runs on their infrastructure, which is huge. But that is, and that can be, a bottleneck if there are problems that occur, and this has happened a couple of times in the past. There's one in late October, for example, or nothing happened during Hurricane Sandy, but it could have been. It could have taken out one of their data centers in a certain region. You don't want your main line of business going down. So as your presence and as your business that you've deployed 100% in Amazon grows, it is something to really start to consider, to have maybe more an on-premise solution as well too, and maybe burst into Amazon. So therefore, if they do have one of their regions where your code base is installed go down, or one of the availability zones in their region have that go down, then you do still have a backup. Another way of doing it would be to just deploy in multiple regions, have something in US East and in US West. In case a natural disaster occurs, you're kind of covered off, and you allowed some load balancing to happen between the regions. It is something to consider once you get kind of beyond that startup phase, beyond that, well, we just need to get our idea out there and do as cheap as possible phase.
Right.
And we've seen some of our clients that have really deployed in Amazon really think that part through and leverage that scenario, and either just purely use Amazon to burst, or do have some redundancy within their own on-premise infrastructure.
So what are some of the security considerations?
Okay, so we had to, it was part of the talk, we do have to talk about security. So there's multiple layers of security to consider here. There's the APIs that you're pushing out, there's security, but it's not really Amazon specific per se. I mean, when you do deploy something into an AMI or into an Amazon instance, you are publicly on the internet if you so have considered their front-end firewall, their security group. So you do have to be careful to have the usual considerations. Are you going to use SSL with your clients, or mutual auth SSL, or are you going to use some of the other all the cool kids are into these days, which is OAuth or some flavor of that. That is one consideration. Layer 7 does that really well, but I don't know if that's necessarily maybe the topic for this talk.
Yeah, no.
Another way of looking at it is, okay, now I'm actually running in someone else's infrastructure. How much do I trust that infrastructure?
Right.
And also, this server I don't have physical access to. It is sitting out there somewhere in the world. I approximately know where it is. I know which state it's in, but I don't know exactly where it is. So how do I harden it so there isn't there's lower likelihood of kind of the wrong hands getting onto it? And so with Amazon instances, with AMI instances, there's some best practices that both Amazon pushes and that just should be thought of well. I think the number one thing is, with each image that you put up, it's access to it that should be locked down. So I'm going to go down the Linux kind of path, just because I'm not too familiar with how to really harden a Windows image in Amazon. But with Linux, I mean, it's very much, most people access it using SSH. So it is highly recommended to use SSH using SSH keys to disable password-based authentication. I know when we were kind of initially going down that path, actually the director of my group, he put up an early image that we had, this is a little while back, and he noticed that within a very short period of time there was a lot of password hack attempts that were done, and it's just because it's a public image. So it's really important to kind of use SSH keys. Amazon does encourage it themselves. They have their own capabilities for generating SSH keys, both the private and the private side that you can download, and you can generate the public side if need be. But that is for sure recommended. Also, really tweaking your firewall settings, so both on-box and also the security group settings that they provide as well, which is kind of the onion layer around the images themselves. So really tweaking and ensuring that you allow incoming traffic on the ports that you want to open and from the sources that you like. With them, you can really tailor the sources, not just CIDR IP based, but you can also do it for security groups that pertain to other images within the Amazon infrastructure itself, and even tailor it to security groups that pertain to their front-end load balancers. So you can have certain ports that you open up that just the front-end load balancers kind of send traffic to, again, for health checks. So again, really kind of paying attention to those details is important, just to minimize any risks. When it also comes to leveraging auto-scaling and elasticity, another thing that kind of ran into, and it's one of the finer points that should be really thought about, is when you do elasticity, when you do bursting, usually you're talking to some other secure resource as well. Maybe your application is storing its data in a database that is not on the box itself. So you need credentials to access that database. where do you securely store this? So as you're bursting, you can kind of access it, and so you don't store things like passwords on your AMI images themselves. So this is another thing that kind of really needs to be thought out. I know we've run into this before, and there's various avenues of doing it. You can either leverage scaling solutions, cost scaling solutions like a right scale, and I'm still trying to kind of understand how securely they'll store your credentials for you, but I mean they have major skin in the game, so they seem to be successful at it.
You rely on them.
You rely on them, so
okay.
So when you kind of scale and you need to, your new image needs to connect to a database, you need to obtain your user ID and password for that database from somewhere. You can either burn it onto the image itself, or maybe mount an ABS snapshot that you pull the information out of, or you have some other offsite service that you call and pull this information from. And how do you trust that? How do you ensure that you're securely communicating with that? It's kind of, these are the finer points that really ensure that you have an overall secure solution and that your APIs and the platform that you're pushing your APIs out of are secure. Kind of for the full loop back.
Yeah.
Yeah. Cool.
I'm just going to remind everybody that we're kind of up against the clock, and we generally go like 40, 45 minutes. So, you know, I apologize again for what happened in the beginning with the stream. It's a live talk, so occasionally that's going to happen. But we really appreciate you guys sticking around and waiting for Rod to talk about the cloud.
Yeah.
So if you have any final questions, now would be the time to chat them in. And I just wanted to say you also may be interested in, we've got a webinar coming up on February 7th, and it's how to implement an API strategy everyone will love. So more of an API design.
Yep.
And you can go to the website, layer7.com, and navigate to the events and webinar page and sign up there. So Mike Amundsen is going to be giving that one, and it should be interesting. So again, it's February 7th. Any other final questions? Any other final thoughts? I want to say thanks to Rod, too, for being so flexible and patient. Thanks to Jose. He's off camera running the stream, and I appreciate that a lot.
Oh, we have a question.
Okay. Where'd you get that shirt?
That might be. Oh, yes, it is. It's a Layer 7 shirt, actually, kind of promoting our new newish Apify service. I think I do have like Apify and Layer 7 on the back as well, too.
That's Apify, which is our kind of our cloud-based API management solution.
Yeah. Thank you. It's actually the gentleman. Some of the gentlemen that designed it might be in this room, in front and behind the camera.
That's a Jose design.
Yeah. I gotta give shout outs to Jose.
But yeah, thanks for the questions, guys, and thank you for sticking around and being patient. That was like 15 or 20 minutes of waiting, and we really appreciate that. So keep an eye out for the next Tech Talk, which it's probably going to be in the third week of February, and might be talking about mobile applications. But again, thanks so much. Thanks, Rod.
Thank you.
Appreciate that.
Thanks, guys.
Thank you.